far, since I have introduced you to I, we first simplified with it, then we added and subtracted and multiplied. Today we're going to take a look at raising I to some big powers and dividing. Let's start with some powers. The first thing I need you to learn is this loop. We're going to have I to the 0, I to the first, I squared, and I cubed. Anything, and I mean anything, to the 0 power is 1. Anything to the first power is itself. Yesterday we learned that I squared is -1, and today I'm going to add on that I cubed is -I. Here's our steps. We're going to take whatever exponent we have, whatever I is raised to, and divide it by 4. Then we're only going to look at the denominator, or the remainder rather, not the denominator, sorry. Our options are this. We're not going to have a remainder at all. We'll have 0.25, 0.5, or 0.75. If you have none, that's 0. If you have 0.25, it's 1, and it's going to go up to 3. The best way that I remember this is think about quarters. 25 cents is 1 quarter, 50 cents is 2 quarters, 75 cents is 3 quarters. Once we have that, we're going to replace our I and then evaluate. So let's take a look at what I'm talking about. When we dive into these examples, I have 3 of them. We are going to simplify with I to a crazy power. Now, these questions are going to increasingly get more difficult. So the first one is going to be pretty basic. So as I give these problems, make sure you're following the directions. So we have I to the 42nd power. Take 42 and divide it by 4. When you do that, you get 4.5. The remainder is the part that you need to know. So 0.5 goes along with 2. So I to the 42nd power is just I squared. And we know that I squared is -1. Notice that I'm writing that in red, so that means it's my final answer. So now let's try one that's a little bit more challenging. Number 2, we're going to have -6 I to the 14th power. Now to the 17th power. Now, when we go to evaluate this one, all I want you to look at is the I to the 17th power. More specifically, the 17. Take the 17, divide it by 4. When you do that, you are going to get 4.25. The remainder is the important part. 0.25, 25 cents, that's 1 quarter. So I to the 17th power is just I. Now we need to replace I to the 17th power with that singular I, so I get -16I. Let's try one more that's just a little bit more challenging. This is number 3. This time, we are going to have 3 plus 2I to the 63rd power. All I want you to start with is the I to the 63rd power. Take that 63, and you guessed it, divide it by 4. When you do 63 divided by 4, you're going to get 14.75. That 0.75, that's your important part. 75 cents, 3 quarters, that's going to translate to I cubed. But I cubed is -I. So let's rewrite this. So we're going to have 3 plus 2 times -I. When you go to simplify that, you're going to get 3 minus 2I. Now with these, they just take some practice. They're a little awkward, but as long as you're following the steps, you'll get there. So now let's take a look at some examples where we divide. Now when we go to divide, there are 2 versions, but no matter what the version, there is a very big, simple rule. And that rule, or there's 2 of them really. The first one is that I is never, ever, ever, ever allowed in the denominator. And that's because at the end of the day, I is the square root of -1, and square roots aren't allowed in the denominator. The other piece is that final answers can only have I to the first power. Now it could be -I or it could be positive I, it doesn't matter, but I cannot be to any other power but 1. So let's take a look at our very first version. So this example, I've got 3 plus 8I divided by I. Now you're going to take what is ever in the denominator, if there's only one piece, and multiply it by I over I. You're allowed to do this because anything over itself in a fraction, it's equal to 1. So now I'm going to give that first numerator some parentheses to remind you to distribute. So when I distribute, I'm going to get 3I plus 8I squared all over I squared. Now, we learned yesterday that I squared does some fun things. It's going to cancel out, and it's going to take whatever's in front of it and change its sign. So it's going to become -8, and the denominator is going to become -1. Now, let's rewrite this. Now I'm going to have -8 plus 3i over -1. You could leave your answer like this, but the better answer is to evaluate that -1, which just changes signs. So my final answer is +8 minus 3i. But please recognize that both of them are correct, and I would accept either answer. Let's try this again. So number 2 is going to look a little bit different, but its process is going to be the same. Let's take a look at 3 plus 10i over 5i. Even though this I has a 5, I'm still only going to multiply by I over I. I'm not going to forget to put parentheses around 3 plus 10i. Those parentheses remind you to distribute. I know it sounds silly, but it's something that it's very easily forgotten. So when you go to distribute this I, we're going to have 3i plus 10i squared over 5i squared. Again, don't forget, I squared, that equals -1. So it's going to change some signs. So that's going to become -10 and -5. So when we go to write this, we're going to have -10 plus 3i over -5. You could leave your answer like this, but what you're going to notice that I do is I'm going to change all those signs because I don't like having a negative on the bottom. So that's going to give me 10 minus 3i over 5. Okay, now we're on to example, or really it's just the second version in this example set. So when we go to these, something is clearly going to change. So number 3, we're going to have 3 minus I divided by 2 minus I. Do you catch the change? This time, there's a binomial in the denominator. So here's what we're going to do. We're going to take a look at that denominator. In this case, it's 2 minus I. We're going to multiply the top and bottom by, watch this, 2 plus I. Those are called complex conjugates. So one has to be positive, one has to be negative. Okay? That is going to be very, very, very important. So now that we have 2 sets of binomials, we are going to FOIL a lot. Now, when you go to FOIL this, it's very easy to try to do a whole lot at one time. Resist the urge. Just FOIL first. So when I FOIL the top, I'm going to have 6 plus 3i minus 2i minus I squared. Leave it. Resist. Then FOIL the bottom. 4 plus 2i minus 2i minus I squared. Now that I FOILed everything, let's talk about what happens. First of all, I squareds change. So those are going to add plus 1s on the edge. So if there isn't a number, make sure you add in a 1. Now check this. See that in the middle that I'm crossing out there? That will happen every single time. And if it doesn't, pause and check your work because you probably did something wrong because it's supposed to happen. So now when I combine like terms, I've got 7 plus I over 5, and just like that, I'm done. If you try to do too much, it's really easy to get mixed up. Give yourself space and time to think. Let's try this one again. So now let's take a look at 2 plus 8i over 4 minus I. Okay, again, we are going to consider the denominator. The denominator is 4 minus I. So I'm going to have to multiply the top and bottom by 4 plus I. So the denominators need to look almost exactly the same. One has to be plus, one has to be minus. Now, let's FOIL. So I like to put some parentheses to remind me, but when I go to FOIL, when I get the top, I've got 8 plus 2i plus 32i plus 8i squared. Remember, resist the urge. FOIL the bottom. 16 plus 4i minus 4i minus I squared. Now let's simplify some things. So my I squareds are going to go away and change the signs. So that's going to become a -8 and a +1. Then my 4i's cancel, just like I said they would. Now let's simplify. Wait, those 8's go away. 8 minus 8 is 0. So I've got 34i over 17. Notice that I didn't write it in red because 34 over 17, it simplifies. 2i. Now it's your turn. These, you just gotta practice.